Understand the kernel trick. Kernel trick is used to teach linear classify to classify a nonlinear dataset in machine learning. It transforms the linearly inseparable data into linearly separable data by projecting it onto a higher dimension. A kernel function is applied on each data instance to map the original nonlinear data points into some higher dimensional space in which they become linearly separable. The linear classifier relies on inner product between vectors k that have an xi xj equals xi to the power t multiplied by xj. If every data point is mapped into a high-dimensional space via some transformation phi in the ratio of x pointing to phi of x, the inner product becomes k of xi xj equals phi of xi transform phi of xj. A kernel function is a function that is equivalent to an inner product in a feature space. Here's an example. Thus, a kernel function implicitly maps the original nonlinear data points into some higher dimensional space without the need to compute each phi x explicitly. Demo voice classification. Problem scenario. Motion Studios is the largest radio production house in Europe. Its total revenue is $1 billion+. The company has launched a new reality TV show called the Star RJ. The show is about finding a new radio jockey who will be the star presenter on upcoming shows. In the first round, the participants will have to upload their voice clips online. The clip will be evaluated by experts for selection to the next round. There is a separate team in the first round for evaluation of male and female voices. Also, the response to the show is unprecedented, and the company is flooded with voice clips. As a result of this, there is a need to classify the voice as either male or female so that the first level of filtration is quicker. Let's go ahead and import the required libraries. Import matplotlib and Seaborn to perform visualization tasks. The Warnings module was introduced in PEP 230 as a way to warn programmers about changes in language or library features in anticipation of backwards incompatible changes coming with Python 3.0. We will now load the corresponding dataset using Pandas. Since we have loaded the data, let's explore the same using some of the data exploration techniques. It is clear now that the data set has 4,000 entries. Hence, it is important to check if we have got any missing values. The results of isNull.sum turns out to be 0, which clearly states that there are no missing values in our data. Let us now get the shape of our data so as to record the total number of labels. Now, record the total number of males. Similarly, record the total number of females. Extract the target variable within X. Since we are able to solve a classification problem, the labels must be converted to numerical form. So with reference to the previous demo, we can use label encoder. Extract value of last column within Y. Initialize the label encoder. Here we will encode the categorical labels so that male gets encoded to 1 and female gets encoded to 0. Now, to make the model efficient, we will have to scale the training data between 0 and 1. Import standard scaler from sklearn.preprocessing. Initialize the standard scaler. Fit the scaler over the training data. Use transform function to apply the transformation on X. Import the train test split function within the sklearn.model selection module. Let's proceed now with splitting the data between training and testing sets such that the training to testing ratio is 70% to 30%. Now it's time to train a support vector machine classifier. Call the SVC model from sklearn and fit the model to the training data. Call the SVC model from sklearn and fit the model to the training data. Import the classification report and confusion matrix classes within the sklearn.metrics library. Initialize the SVC model. Fit the SVC model on the training sets. Perform prediction on the testing set. Now get predictions from the model and print accuracy. Create a confusion matrix and classification report with respect to y_test and y_pred. Let's see if you can tune the parameters to get even better. Probably we would be satisfied with these results in real life because the data is quite small. But it's always a good practice to optimize the results. We must try the same using grid search. Create a dictionary called param_grid and fill out some parameters for C and gamma. Initialize the grid search.